Dear students, welcome to today's class. Today I am going to explain a very important topic, that is period and periodicity of a function, whatever may be that function. Maybe trigonometric function, maybe algebraic function, whatever may be that function. What is meant by period and periodicity of the function? Okay, now it is a very important concept. So even though there won't be any direct questions from this chapter, but this concept is a very useful for to solve the problems in calculus and trigonometry also. Okay, na? So next let us start the class. So before explaining the concept period and periodicity of the function, first I am taking the graph of a function. Clearly everybody can say this is the graph of y is equal to sin x graph S. As it is a y is equal to sin x graph. Sin 0 is equal to 0, sin pi by 2 is equal to 1, sin pi is equal to 0, sin 3 pi by 2 is equal to -1. It goes on. Coming to the negative direction, sin minus pi by 2 is equal to -1, sin minus pi is equal to 0, minus sin minus 3 pi by 2 is equal to +1, sin minus 2 pi is equal to 0, sin minus pi by 2 is equal to -1. It goes on. So everybody knows that this is a sine function, the graph of a sine function. Okay, now what do you observe here? What are the characteristics of the graph? What can you, the conclusions we can derive from this graph, that we have to observe. The first thing what you have to observe is, everybody can say that this graph is passes through origin. Okay, everybody can say that is the first point. Second point is, the graph intersects the x-axis at pi, 2 pi, 3 pi, 4 pi. Coming to negative direction, minus pi, minus 2 pi, minus 3 pi. That means the graph intersects the x-axis at n pi, where n is an integer, 1, 2, 3, 4, 5, like that. The second one is, the graph takes the maximum value at pi by 2 and 5 pi by 2, again 9 pi by 2, like that, and the minimum value at 3 pi by 2, 7 pi by 2. So what is the maximum value it takes? 1. What is the minimum value it takes? -1. Negative direction also, the maximum value is 1. It obtained at minus 3 pi by 2, again at minus 7 pi by 2, it goes on. And what is the minimum value is -1, right? That is the conclusion we observe. And the next conclusion is, it is symmetric symmetric with respect to the origin. Okay, now symmetric with respect to origin, right? After that, the one very important topic that we have is this function have any what you call that periodic nature. What is meant by periodic nature? Generally in our class, in our school, for every 30 minutes there is a period. Otherwise every 45 minutes there is a period. Otherwise every 50 minutes there is a period. So morning school starts at 8 o'clock. 8 to 8:50 first period, 8:52 again 9:40 second period, 9:40 to 10:30 next period. Like that the periods will go on. We know that. That means every 50 minutes interval, 50 minutes interval, there will be a period. We call it as a period. Here also, if you observe in which interval the shape of the graph is regaining, that means regaining and getting original shape. Now first I will explain with positive direction. I will explain with the positive direction, afterwards I will come to negative direction. From here, from origin, from 0 onwards, if you see that 0 to, next I will move it like this, 0 to pi, pi to 2 pi. See here, up to here, that is a one shape. Understand? This type. That means up and down. Again, if you see this the same shape is regained on second period, first period. This is the first period from 8 to 8:50, first period. Again 8:50 to some 9:40, 8:50 to 9:40, 50 minutes, second period. So this is the, from here on, so same. Are you observing or not? That is second period. So this is the first period, second period. Same shape you are gaining or not? First of all, if a graph has that type of nature, then we will say that the graph is periodic in nature. Not all the graph will have the shape, that type of graphs. For example, there are some graphs are there, some oscillatory functions graphs are there. If you observe those graphs, they will be like this, they will be like this, they will be like this. They are called oscillatory functions, There is no period, nothing here. There is no period, nothing here. They will come zigzag like anything. But observe here, this graph has every 2 pi interval. Here, for in our class, in our school, in our college, 50 minutes is the period. Generally wherever you go, 50 minutes is the period. But here 0 to 2 pi, what is the length here? 2 pi. The 2 pi is the period of this function. Again 2 pi to 4 pi, what is the length? 2 pi. That is a 2 pi is the period of the function. Okay na? Coming to the negative direction. Here also, if we observe here from 0 to, see here, observe down and again up, down and up, again down and it will come up. So if you observe here, down and up, again down and up. So every length of 2 pi interval, it is regaining its same position. See here, again coming here. So that means from here down it is coming, again up, again down coming, again up coming. Okay, 0, minus pi by 2, minus pi, minus 3 by 2, minus 2 pi. That means see here, 0 to coming here, down. Again that means down, 1 up, 1 down, 1 up, like that. So here it will be minus pi, minus 2 pi, minus pi, it will be minus 4 pi. Understand this? So every length of 2 pi interval, the graph is regaining and again getting the same position. So that is called period of this function, sine function. So therefore the period of y is equal to sin x graph is 2 pi. You may ask one doubt, sir, sometimes first period is 2 periods, though both periods together, one sir will take both the first period and second period, both periods he will take the class, he will continue the class. If you observe here, graph from 0 to here, 2 pi, again 4 pi, up to here you take complete graph, this is 4 pi, 0 to 4 pi, again 4 pi to 8 pi, again 8 pi to 12 pi, getting the same shape or not? Again getting the same shape it or not? Yes. Therefore, for the period of y is equal to sin x is a 2 pi, 4 pi, 8 pi, again 12 pi, so on 2n pi, so on 2n pi. All these are all called periods, So if anybody asks you what is the period of y is equal to sin x means, you may say that 2 pi, 4 pi, 8 pi, 12 pi, so on 2n pi. But the question is, in this, sir, which we have to consider means, we will take for definition purpose, we will take the smallest interval. What is the smallest interval? Least positive real number. What is the smallest interval? 2 pi. Here what is the smallest interval? From 0 to 2 pi. Again 2 pi to 4 pi. This is the smallest interval. It is the smallest interval in which the graph is regaining its shape. Now 0 to 2 pi. This is the smallest interval. That's why this 2 pi is called the period. So these are all the periods. So the period of sin x is equal to 2 pi. Understand? So actually I should not write the period here. I have to write down the periods of, what are the periods of sin x? 2 pi, 4 pi, 8 pi. What means for every interval of 0 to 4 pi, the same 4 pi to 8 pi also same shape will come. That means 2 ups and 2 downs. Same shape it will be regained from 4 pi to 8 pi also. If you consider from 0 to 8 pi and 8 pi to 16 pi, 0 to 8 pi and 8 pi to 16 pi also same grade. Same logic applies for negative direction also. Here we have to take from 0 to 2 pi, 1 down, 1 up. Minus 2 pi to minus 4 pi, minus 2 pi, minus 4 pi. 1 down and 1 up. Here we have to consider the length of the interval. From 0 to 2 pi, what is the length? 2 pi. Length is always a positive quantity. From 0 to minus 2 pi, the length is 2 pi. From minus 2 pi to minus 4 pi, so the smallest interval is what? 2 pi. That 2 pi is called the period of the function 2 pi. The period. The period. We have to use the word the period. All these are all periods. The period means 2 pi. Smallest interval we have to take. For this function, sine function, we got 2 pi. For other function, we will get another interval. There are certain functions in which there is no periodicity. Since there is no periodicity, there is no period. Understand? So now let us see the definition of periodicity of a function. Okay now? So let us see the definition. Welcome to the definition of periodic function. A real function f from a to r. A real function f from a to r is said to be a periodic function. Is said to be a periodic function. Definition. Every definition. In the definition, each and every word be carefully observed. Learn this. A real function f from a to r. A is a subset of real numbers. Is said to be periodic function. See here, what is that word is there? If. If means what? If there is exist, that means there is no compulsory. There is no compulsory. If there exists a positive real number, why you have to take the positive real number? Just before only I explained that we have to take the length of the interval. The length of the interval, we have to take the length of the interval. Length means always a positive quantity. Length means always a positive quantity. A positive real number p. That p may be 2 pi, 4 pi, 6 pi, 5, 6, 10, like that also. Whatever may be the number, it is a real number. Moreover, positive real number p such that f of x plus p is equal to f of x for all x belongs to a. A means what? Domain of the function. What is a? A is the domain of the function. Means for every number, whatever of every x you take for every x from the domain, if you apply f of x plus p is equal, that means x plus p, p is the interval. Again you are getting the same shape f of x. That means in place of for every x plus p, you are getting same, regaining the same shape. That's why this p is called positive real number. P is called the periodic. If there exists, then it is called the periodic function. The least value of p, the least value of p is called the fundamental period. The fundamental period of the function f. Understand? So now, just now I explained one example. So what is that? Sine function. Let us take the function f of x is equal to sin x. As we know that f of x plus 2 pi, that is sin of x plus 2 pi. I will write down for my convenience sake, sin of 2 pi plus x. X plus 2 pi or 2 pi plus x. Already in trigonometry I explained that sin 360 plus theta. Sin 360 plus theta means again it will go to first quadrant. First quadrant is sin is positive. Again you are getting f of x. That means what value you are substituted here? 2 pi. Again you are getting f of x. You may ask one doubt, sir, what is that, sir? If I substituted f of x is equal to 4 pi, that is equal to sin of 4 pi plus x. Sin of 4 pi plus x is also in the first quadrant. 2 pi means one complete rotation, 4 pi means 2 complete rotations, plus x means again it will go to the first quadrant. There you will get again sin x, that is equal to f of x. Therefore, this 2 pi is also a period. This 2 pi is also a period. Not only 2 pi, 4 pi, 6 pi, 8 pi, all are called periods of that function. Out of that, what is the definition? The least value of p, the smallest value of p. Which is the smallest one? 2 pi or 4 pi or? Right. Understand this? 2 pi or 4 pi? 2 pi or 4 pi? Which is the smallest one? 2 pi. So that's why that 2 pi is called the fundamental period or simply the period of the function sin x. Understand this? So the same logic will apply for cos x, tan x, cosecant x, secant x, cot x. Understand? So first you have to understand what is the periodic function. Periodic function means if there exist, if there exist a positive real number such that f of x plus p is equal to f of x. That means in place of x, even though you substituted x plus p, again you have to regain the same function for all x belongs to a in the domain. Understand this? Then the least value of the smallest value of that function is called the period of the function. Okay, I hope that you understand the what is the periodic function and what is the period and the periodic nature of the function. Okay, now we are going to see the periods of the all six trigonometric functions. Okay, so let us continue the class. Let us see the periods of the fundamental trigonometric ratios. So there are the 6 fundamental trigonometric ratios. So the period of sin x is 2 pi, the period of cos x is also 2 pi, whereas the period of tan x is equal to pi. Why, sir? So you can draw the graph and you can observe from the graph. Otherwise, very simple reason is, so tan of pi plus x is equal to tan x. That is known fact, tan of pi plus x. Actually, tan of 2 pi plus x is also tan x. Why? Because 2 pi plus x, first quadrant, again tan x will come. Pi plus x, it will go to third quadrant, tan is positive. Tan of pi plus x is equal to tan x. So not only pi, 2 pi, 3 pi, 4 pi, like that. But out of which is the least positive real number? Least positive real number is pi. That's why for tan x and this is a cot x. So this is cot x. For tan x and cot x is pi. For sin x, cos x, cosecant x, secant x, it is 2 pi. So there are a very fundamental trigonometric ratios. You should be keep it in your mind always. For sin x, cos x, cosecant, secant x, 2 pi. For only tan x and cot x, it is pi. Right. Coming to these modulus functions, modulus of sin x, modulus of cos x, modulus of tan x, modulus of for all modulus, period is pi. Why, sir, period is pi means? I will show you very small. Okay. First, I will draw the graph of sin x. Okay, very simple graph. Okay, for my convenient take only, I will take the only positive side. So negative side also same thing will come. So here it is 0, this is a pi by 2, this is a pi, this is 3 pi by 2, this is a 2 pi, this is a 5 pi by 2, so this is 1. Now what will be the your sine graph? So this is equal to sin x, first I am writing y is equal to sin a graph, 0, pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2 it will come. So that is the graph of the y is equal to sin x. Now what will be the graph of y is equal to modulus of sin x? What will be the graph of y is equal to modulus of sin x? So while drawing the graph, so everybody knows that whenever this modulus will come, for function modulus will come, whatever may be the graph which is below the x-axis, exactly is the mirror image you have to take. Mirror image means what? For example, this is above the x-axis, no problem. Here it is below the x-axis. That means you have to take the mirror image. So this is y is equal to modulus of sin x. So this is a modulus of sin x. This, like this it will come. Hills, like that will come. Just like same like hills it will come. So whatever may be the from pi to 2 pi, it will be in the down below the x-axis. All whatever may be the graph below the x-axis, it will go same as it is mirror image. Just like x-axis is the symmetric line for that. X-axis will be the symmetric line. Of course, whichever it is below the graph, it will go above the graph, above the x-axis. Okay. Now you observe here, clearly you can say from 0 to pi, pi to 2 pi, 2 pi to 3 pi, that means every pi interval, 0 to pi, every interval of length pi only, every interval of length pi only, it is regaining its same shape. That's why for all sin x, cos x, tan x, modulus of sin x for period is 2 pi, not 2 pi, it will still reduce pi. Understand this? So I hope that you understand this graph. If you observe the graph, so whatever may be the problems, if you draw the graphs, from graphs you can derive the so many conclusions from the graph. Okay na? So I hope that you understand this concept. Let us see periods of some more functions. Here we have seen the individual functions, sin x, cos x, tan x, cosecant, secant, cot, modulus of sin x, modulus of cos x. Now what is the periods of combination of the trigonometric functions? That means sin x plus cos x, tan x plus cot x, like that. What are their periods? Let us see the periods of the combination of the trigonometric functions. So here the combination of modulus of sin x plus cos x is pi. See here, sin x plus cos x, there is no period. For sin x plus cos x, there is no period. It is not a periodic function. See here, modulus of sin x plus cos x, modulus of sin x minus cos x, the period is pi. So what is the proofs are? Very easy proof. So that is equal to f of x is equal to modulus of sin x plus cos x. This is equal to modulus of sin of pi plus x plus cos of pi plus x. So this is equal to minus sin x minus cos x. That is equal to minus of sin x plus cos x. This is equal to modulus of, this is f of x plus pi. This is equal to sin x plus cos x, since modulus of x is same as modulus of minus x. Again you are getting f of x. That means wherever x is there, substitute pi plus x. Wherever x is also there, substitute pi plus x. You will get the again same function you will get. Therefore modulus of sin x plus cos x is pi. Modulus of sin x minus cos x is pi. Okay now. Here also tan x plus cot x is equal to pi by 2 only. Why? Because tan of pi by 2 plus x is equal to minus cot x. Cot of pi by 2 plus x is minus tan x. Again tan will become cot, cot will become tan, minus if you take common outside, again you will get tan x plus cot x. Of course modulus. Here also the same story applies. Here also modulus of sin x plus modulus of cos x. Here see here, so in place of x, if you substitute pi by 2 plus x, then what you will get? Sin of 90 plus theta, cos theta you will get. Here cos of 90 plus theta minus sin theta you will get. Of course minus means again it will get modulus of sin x. That means modulus of cos x plus modulus of sin x will come. Therefore, the period only pi by 2 only the period. See here pi by 2, for this also pi by 2. So, these are the periods of the for functions which are combination of trigonometric functions. Okay. So, let us see some more concepts. Welcome to this concept. So, there are some combination of functions are there. So, here combinations of functions are there. So, here I have said that n is a positive integer, n belongs to z plus sin power 2nx plus cos power 2nx, otherwise secant power 2nx cosecant power 2nx, otherwise tan power 2nx plus cot power 2nx. For these functions the period is pi by 2. How, sir? For example, take n is a positive integer. Positive integer means what? Natural numbers. All natural numbers are called as positive integers. Okay, you can take in place of z plus, you can put n. So, here you can take n is equal to 1. Then this will become sin square x plus cos square x. Its period is pi by 2. Okay, now. Not only that, sin to the power of 4x plus cos to the power of 4x. Period is pi by 2. Not only that, sin power 6x plus cos power 6x, period is pi by 2. Right? It goes on, goes on. Okay, now. But observe here, sin x plus cos x is not there. Why? Because here 2n means even numbers. 2, 4, 6, it goes on. Now, if in your examination, so in the next examination, if anybody asks you what is the period of sin power 2022x plus cos power 2022x, what the period is? Pi by 2. Clearly pi by 2. Why? 2022 is a multiple of 2, that is a even number, therefore that period is also pi by 2. Okay, now. So, the same concept applies for here also. If it is a sin and cos combination is there, where n and m are positive integers. N m and are positive integers means we can take any problem. For example, in place of 2 sin square x plus 4 cos to the power of 4x, its period is pi. Understand this, its period is pi. Okay, now, right. 2 sin square x plus cos power 4x. The condition is sin square x cos power 4x. So, you can take, there is no need of taking n and m value, same value. You can take different values also. Here if I take n is equal to 1, if I take m is equal to 2, a and b are any real numbers you can take. Okay. Therefore, so I have taken 2 sin square x plus I have taken b cos power 4x, its period is 4. Okay. The only thing is the observation means here power should be even numbers. Power should be even numbers. Here also even number, here also even number, 2n, 2m, 2n, 2m, 2m, 2m. Okay, now, right. So, I hope that you understand this concept. Why? Because for in future, if anybody asks you to what is the period of some 5 into sin to the power of 2024 x plus 7 into cos to the power of 2026 x, what is the period is equal to pi. So, 2024 is an even number, 2026 is also an even number. Forget about this 5 value, 7 value, 5, 7, forget about that. So, the period is equal to pi. The proof is simple, very easy. In place of x, substitute pi plus x. Here also substitute x, pi plus x. Since they both will go to in the third quadrant, negative will come, but 2024, 2026 all are even numbers, no? The negative will becomes positive, that's all. The negatives will become positive. Again, you will get the period pi. But here we have taken pi by 2 means here sin or cos is there. Sin will become cos, cos will become sin when pi by 2 plus x is there. That is the logic behind it. So, if you think like that, if you think in a proof also, in the proofs also, if you think, you never forget, So, if you by heart this, you never forget. So, here sin cos is there, top even number is there. If you put pi by 2 plus x, it will become cos, cos pi by 2 plus, if it becomes sin, again you will get in the same, that is why period is pi by 2. Understand? So, but here, here 2 power n, here 2 power m is the powers are different, that is why here the period is equal to pi. Okay, now. So, I hope that you understand this concept very easily. powers are different, and moreover here coefficients are there, a and b. So if you put pi by 2 here, what happens? This will become cos square x and become, this is sin power 4x, but the coefficients are different, no? Here 2 is there, there 4 is there. Here coefficient is 1, here also coefficient is 1. That's why sin will become cos, cos will become sin for pi by 2 only, small number. But here coefficients are different, a and b, maybe same, maybe different. Here the powers are also different, here 2n, there 2m. For that the period is 2 pi. Okay, na? So dear students, I hope that you understand these concepts. So now in the next class, so far what are the functions we have taken? We have taken x coefficient is 1. Sin x, cos x, tan x, sin x, cos x, tan x. If it is x coefficient is not x, that means what is the period of sin 2x? What is the period of sin 2x? Here x coefficient is what? 2. Is it 2 pi or something less than 2 pi? That we are going to see, okay, in the next class. Okay, I hope that you understand today's concept and you enjoyed today's concept. And in the tomorrow's class, I am going to explain if the coefficient is x coefficient is other than 1. That is, if it is a 2 is there, 3 is there, and if it is what about the period of sin of some 2x plus 3 is there, that is the period. Okay, now how that we have to take like that again. So the period of some 2x plus cos of 4x. How to find the periods of these type of functions, sin 2x plus cos 4x. Okay, how to do again? Otherwise sin 2x into cos 4x, otherwise sin 2x by cos 4x, multiplication, divisions, all those type of functions in the next class I will explain. Okay, so I hope that you enjoyed today's class. So all the best.